Hey there, guys. All right, this is the pumpkin chunkin activity. Um, so first, we're going to talk about the pumpkin chunkin, and then we're going to talk about the pumpkin drop. Well, most of our work today will be pumpkin drop, but we're going to talk about this pumpkin chunkin in the very beginning here. So pumpkin chunkin um, is it's this event that happens somewhere, I don't even know where they throw pumpkins with catapults. And so imagine a giant version of Angry Birds. But you were throwing a pumpkin and it was real life. And so they throw them really high and really far. And so that's what we're going to think about here. So number one, which of these graphs fits the pattern related to pumpkin height? So imagine a pumpkin thrown Angry Birds style across a big open field. And so what they want to know is as time goes on, so as it's in the air, what happens to the height? And so if we think about it, imagine it in your head. Um, we launch the pumpkin and it starts going up and out. And it's going fast right when we shoot it, so it's getting higher and higher. And it's getting higher fast, but as it gets higher, it kind of slows down to where it doesn't get higher as fast, and then eventually it turns and it starts dropping. So it reaches a maximum height and then it starts dropping. And when it starts dropping, it's dropping slowly at first, but then it picks up speed as it goes until eventually, right before it hits the ground, it's going really fast and it's dropping really fast. So when we look at these, number one is what we want to see. And so if we look at the slope, in the early part, you can see that it's really steep, so it's getting higher fast. But then it starts to level out, so it's not gaining height as fast until eventually it hits its maximum, its peak. And then it starts coming down, and when it's coming down, it's not coming down real fast at first, but then it gets steeper and steeper to where it's falling faster and faster. And so that's what we want to see. Is we want to see this. We call it a parabola. And so it kind of looks like that example we just did on the homework, but now it's the opposite way. It's upside down. So part B asks about a data table. So let's draw a little data table. So let's say that we do seconds. So 1, 2, 3, 4, 5, 6. Let's say it's 7 seconds that the pumpkin's in the air. And so at 0, the height is 0 because it hasn't left the ground yet. But let's say that after 1 second, it's gained a bunch of height. Remember, it's gaining height fast. It comes out of the gun fast. So let's say it gains 50 feet. Okay? Well, after 2 seconds, it's gained some more height, but it's not going quite as fast. So let's say it only gains 40 more feet. So let's say that now it's up to 90. Okay? And then after 3 seconds, it's going up more, but it's not going quite. So let's say it only gains 20 more feet now. So now it's up to 110. And then at 4, it only gains 10 more feet. So it only gets up to 120. Now on the way back down, we're just going to see that same pattern mirrored. So we're going to see 110, and then 90, and then 50, and then actually, see, I lied. Let's say, and then 8 would be where it gets back to 0. So we see that it's gaining height fast in the beginning. So in this section here, it's gaining height fast. Then it slows down till it hits its peak. It starts to fall slowly, and then as it gets closer to the ground, it falls faster and faster. So that's what we expect the data table to look like. Okay, so that's the end of the first video. I'm going to do another video for the next page.